Disk and memory are arguably the resources that can make the most positive impact on improving client computer performance. Use the following guidelines to help to optimize disk and memory performance in your Windows computer. Select a 64-bit version of Windows. Using a 64-bit version enables your computer to use more memory than the 4 GB limitation imposed by 32-bit operating systems. If your computer has more than 4 GB of memory, or if you can add additional memory beyond 4 GB, then select a 64-bit version of Windows. Avoid shared memory video. Some video adapters use shared system memory. This means that the video adapter uses memory for display purposes that would otherwise be available for servicing applications. Some computers come equipped with video adapters that use dedicated onboard memory for display purposes, ensuring that more memory is available for applications. Optimize paging. For most single disk drive computers that run Windows, leaving the paging file settings at the default values is adequate. However, you might gain a small performance benefit by following these guidelines. Create the paging file on a different physical disk than the operating system disk. Paging is a disk-intensive task. If you distribute the disk load across all of your computer's available disks, you minimize the likelihood of performance bottlenecks affecting the disk subsystem. By optimizing the disk subsystem, you can make the paging process as efficient as possible. If you have a device with an SSD as the primary disk and a normal hard disk as the secondary disk, moving the paging file is not likely to improve performance. Configure a fixed-size paging file. A paging file that can grow on the disk might encompass fragmented areas of the disk volume. By configuring a fixed-size paging file, you can ensure that the paging file does not encompass fragmented areas. On non-SSD drives, ensure that the disk volume is not fragmented when you create the paging file. If you want to create a fixed-size paging file on a computer that already has a paging file, ensure that you do not create a paging file that encompasses fragmented areas of the disk. Additionally, before you create a fixed-size paging file, you should configure the computer to use no paging and then defragment the volumes. When you configure the paging file, ensure that its size is sufficient. Recommendations specify that an initial paging file should be equivalent to the amount of installed memory, and a maximum paging file size that is equal to twice the initial value. Consequently, you should create a fixed-size paging file that is equal to or twice the size of the physical memory. Add physical memory to a computer that is paging excessively. If you investigate performance on a computer with a memory bottleneck, you often find that disk performance is low as well. By adding extra physical memory to the computer, you can reduce the load on the disk subsystem and thereby improve both memory and disk performance. Implement faster disks. Disk speed is measured in revolutions per minute, RPM, and average seek times are measured in milliseconds. Install disks running 7200 RPM or faster, and select disks with the lowest seek time. On desktop computers, you also can install a disk controller that supports a faster bus type. The first serial ATA, SATA, standard supports transfer rates up to 150 megabytes per second, MBPs, whereas the latest SATA standard supports transfer rates up to almost 2000 MBPs. Changing your disk controller and disks that support the new disk controller could improve the disk subsystem performance considerably. Consider using SSDs. SSDs use flash memory technology and have no moving parts. They can operate faster than traditional disks, but they are more expensive. Carefully research the specific vendor and model of disk. Some disks provide higher write performance, and some provide higher read performance. In systems that support multiple drives where SSD cost is a concern, consider a smaller SSD drive to store the OS and a SATA drive for apps and data. Defragment volumes that are used heavily. You can use either the built-in disk optimized drives tool or another company's tools, some of which support the defragmentation of files such as hyperfill.sys and pagefile.sys. Windows optimizes drives automatically once a week and will run the proper optimization automatically, defragmenting SATA drives or running trim on SSDs. Ensure that you enable write caching. You can use Device Manager to examine the properties of any installed disks and to verify that write caching is enabled. Distribute the memory load across all available disks. If your computer has multiple physical disks, consider distributing disk-intensive activities across these disks. For example, you can install the Windows operating system and applications on one disk, the paging file on another disk, and your data files on a third disk. Configure Windows Client Search Indexes. Indexing is a technology used by Windows Search. As the name implies, it is an index, a local database. Windows uses this index to keep track of files, folders, file types, data properties, and other details about files so that you can search by those details to locate data more easily. Generally, when you search for a file, Windows accesses this index first. It is important to personalize the settings for indexing to meet your needs. You want to make sure the service is indexing all of the areas of your computer that you use and it does not index unnecessary areas. Contents of the Windows Search Index. One index is maintained per computer, so shared data stored on local drives is indexed only once. In addition, each user's data is distinguishable by a unique user security identifier, SID, so users have access only to their own content. System administrators can use group policy to prevent specific paths or file types from being indexed. Windows Search indexes information as follows. By default, Windows Search indexes each user's email and documents and settings folders. Users can add custom locations like network shares. Indexing of shared folders can be turned off with group policy. Windows Search does not index password-protected Office files. Windows Search indexes email and attachments in a secure environment. Indexing of attachments can be turned off with group policy. The Windows Search index is updated automatically in the background when data is added, deleted, and modified. Index encrypted files. Windows Search 4.0 and higher fully supports indexing encrypted files on local file systems, enabling users to index and search the properties and contents of encrypted files. Users can manually configure Windows Search to include encrypted files, or administrators can configure this with group policy. Windows Search ensures that only users with the correct permissions can search the content of encrypted files by honoring ACLs and by restricting access to users with decryption permissions for the files. Additionally, Windows Search restricts access to encrypted files to local searches only. Windows Search does not return encrypted files in search results when the query is initiated remotely. Note: the indexing of encrypted files should not be enabled unless the search index itself is protected with full volume encryption. While encrypting the index file with EFS is possible, it is not recommended. Summary: client performance is a frequent issue and any number of reasons can be the cause, and the issue itself can be subjective. Establishing baselines for normal performance can assist as reference when validating reported performance issues. Resource Monitor and Performance Monitor provide several measurements for pinpointing the offending hardware or service. Administrators should also be proactive about selecting hardware and configuring devices and services, such as search, to perform optimally.